So in this video, we'll briefly go over how our Smart and Trustworthy Air Quality Monitor, or STAIR, works, and we will highlight a few features of our STAIR monitor. So the main pollutant our monitor targets is PM2.5, or fine particulate matter. Now PM2.5 are those teeny particles suspended in the air. They have a diameter about 2.5 micron or less. That's about 1/40th of the width of human hair. Now, because they are so teeny, it's relatively difficult to measure this pollutant. In the United States, most locations measure PM2.5 in the air is owned and operated by regulatory agencies. For example, U.S. Environmental Protection Agency. In Orange County, we have Orange County Environmental Protection Division. Now, in this location, they use regulatory grade instrument to measure PM2.5, which are very accurate, but they are quite expensive. Usually it costs around $20,000 per instrument. If you want to measure PM2.5 at many different locations, you can also use a portable instrument. For example, this is a beta attenuation monitor, which uses radiation to do the measurement. This is the photometer, which uses a laser to measure PM2.5 in the air. Now, these two instruments cost around $10,000 in that range. So, in this project, what we are hoping to achieve is further reduce down the cost of per instrument to $500. Now, with $500, we can make a lot of them. We can deploy a bunch of the different instruments to different communities, especially those communities who are impacted the most by air pollution issues. Now, to achieve this, we used inexpensive optical particle counters in our instrument. These are two of the OPC, optical particle counters, we plan to use in our monitor. As you can tell, they are pretty small. So how OPC works is similarly as a photometer. But instead of using a pump to draw air inside, this is a pump for this photometer, OPC uses a teeny blower. This is the teeny blower inside the OPC. As you can tell, it's quite small. Now this teeny fan draws air inside the OPC. The OPC will force air go through a carefully designed channel. Now inside the channel, OPC has a small laser source. Now this is the laser source inside the OPC. It's also teeny. This laser source shines a light to the air flowing inside the channel. Now if the air contains any particles, the particles will scatter light. So this OPC has a detector built inside. So the detector will detect the amount of scatter and the intensity of scatter, which translates to how many particles in the air and what's the size of the particles. With this information, we can estimate the weight of the particles, which is the data we ultimately need. Now, because OPC is relatively inexpensive, you would not expect OPC to work similarly in the same performance as the laser component inside this photometer, right? So this brings to one of the unique features of our STAIR monitor. So our STAIR monitor, we designed to allow this monitor to be able to continuously examine the data collected by OPCs. So our STAIR monitor is able to perform automatic calibration to mitigate those inaccuracy issues due to the use of the inexpensive OPC component in there. So this will make sure our data is reliable. Another feature of our STAIR monitor is cybersecurity. Nowadays, the vast majority of monitors available on the market, they lack enough security features, meaning that they are vulnerable to outside hacking. So in our monitor, we designed actually several different methods in both hardware and software levels. So we make sure our entire device is secured, so it can automatically fend off unwanted attacks from outside. So the reason why we do this is we want to make sure our data is trustworthy. And that's why we call our monitor Smart and Trustworthy Air Quality Monitor. Okay, that's all for this video. And as always, if you have any questions, please do not hesitate to contact us at airquality@ucf.edu. Thanks.